Hey everybody, thank you, Martin. Hopefully you can see my screen now, and there should be some scary looking eyes coming at you. So as Martin said, I will be speaking about test-driven development, and my talk is TDD and the Terminator. So this is an introduction, and I'm going to tell you a little bit more about me. So my name is Layla Porter. I've recently been awarded my Microsoft MVP. That was for developer technologies and for a lot of the community work I do, mainly sort of around my local .NET meetup group, which I love, and I love building that community. I am an avid C# lover. And my day job is as a developer evangelist at Twilio, which is a cloud communications API platform. So you're probably wondering why TDD and the Terminator? It seems like an odd choice. Well, in 2017, I was working in a software development house, and we didn't have one unit test in our entire production code. And none of the companies I had worked for before that had any unit tests in any of the production code or non-production code. It was not something I had never worked with, unit tests or any type of testing beyond, say, the client testing, so UAT, user acceptance testing. Now, in this company I was at in 2017, they were heavily reliant on our testing team. So we had 5 dedicated testers, and when we were going for our release and we were hands-off code, we'd hand everything over to our testers, and they would come back with regression bugs, and they would come back with requirements not met. And I started to think that there had to be a better way. And this was after 6 weeks of bug fixing on this code, and I was pretty tired of fixing bugs. So I started to research testing, and test-driven development was a good fit for me, and it seemed to just resonate with me, and I thought, right, I'm going to learn this. So I started to read some books and some blogs, and I didn't get it. I watched some videos and it looked like magic, and I was like, yes, I want to do that, but I still don't know how. So this is why I decided to create my own project, and I called it TDD and the Terminator. I was going to program a T800 series Terminator, and it would give me something to relate to and build my test. So I actually did this. I have been asked, did you really build a Terminator app? I did, and that's how I learned TDD. So I'm hoping that this may give you a good insight into how to get your head around test-driven development. So why do I like test-driven development? What are the good points about this? And some of these you'll say apply to unit testing as well, but I'm going to include them as well. So the biggest thing for me is acceptance criteria. What does that mean? Well, when you have a user story and your project owner has written it and created it, there's a certain set of criteria that will mean that that story is accepted by testing. So you need clear acceptance criteria to be able to write tests before you code. And so I think this is a way of getting clearer instructions from project managers, and everybody's a lot happier about what is expected from the code. So there's less ambiguity at a later date. It gives you focus. Now, I know many developers are ADD, so attention deficit disorder, and you're starting to code and you think, oh, I need to do this, and I need to do that, and I need to have all these different balls in the air to be able to do that. So you lose focus. And one thing about TDD is it keeps you focused, and I'll show you why it does that in a little while. We use interfaces a lot in test-driven development. You may think, oh, well, I use interfaces all the time, but they're very, very important in test-driven development because this is a coding contract. And if you don't have that coding contract, you can't do one of the other cool things which I like doing, which is asynchronous development. So this works well in an agile team. and you work with your co-developers and you all choose the user story that you want, and you can work on different parts of that. And through these coding contracts or interfaces, you know that if there's code that's not been written yet, it's still going to work once it is written with your code. So that's one of the other beauties I love about this. You do get cleaner code. Because you are focused and you're only writing enough code to pass your test, you don't get bloated code. You don't get unnecessary logic. You only get the bare minimum you need to pass your test. And I think that's really important. Safe refactoring. So this goes with any type of unit testing or testing in general. If you have them in place and you need to refactor, you know you're not going to get regression bugs because you have those tests in place. If you break something, it's going to be highlighted. And that leads to fewer bugs. If you can safely refactor when it comes to testing and your users are testing it, they're not going to have as many bugs because you already know that your acceptance criteria is still being met, that you haven't undone some of your good work. And the increasing returns. So one of the stigmas around test-driven development is that it's slow, it takes too long. It does at the beginning, I'm not denying that. But once you have your tests in place and you've got that way of working, your development and output gets increasingly faster. And that's one of the most compelling reasons about this way of working. And the final point I want to raise is its living documentation. Now, I'm not saying this replaces your actual documentation, but if you have a suite of tests and you have a new developer, for example, and they come in and they look at your code, and they're like, oh, I don't really know what this method does. So then they go and have a look at the tests, and the tests are very explicit. X does Y, or X should produce Y. And that's a great way of documenting your code. And you can derive your actual documentation from your tests as well. So let's get back to the Terminator and have a little think about the process of test-driven development. What do we need to do first? Well, I mentioned we need user stories. So I think we need to gather the requirements. So I'm not quite sure what my Terminator needs right now, but if I have a look at this video, I can see, well, we're looking at this boy and we think, oh, we need a closer look at him. And we get the picture and that is a target. This is a person of interest. This happens to be John Connor, so that's definitely a target. But we're looking at a target and seeing if we need to investigate them further. So let's see. That's scan subjects and determine if they require further investigation is one. And then investigate those subjects of interest and determine if they are the target and possibly terminate in this case. So that might be the way forward for us. So I'm going to really focus on this first one, which is scan subjects and determine if they require further investigation. So what we need to do is start with failing tests. And you may ask, why do you need to start with failing tests? Well, when you write tests after coding, you may be writing them to fit your code and not your requirements. And this is the biggest selling point, really, for me over test-driven development. I'll probably say that over a lot of facts. There are a lot of different selling points on test-driven development for me. But this one is that you are actually writing your tests to fit your requirements and not the code you've written. Because it's very easy when you've written code to write tests that pass first time. And your code, oh, you're like, oh, all my tests work. But you don't actually know if that passing code is fulfilling your requirements. And that's a big reason for writing failing tests. So I'm going to show you a pattern called red-green refactor. And it's very pure in its way of doing this. So the first thing is you write a failing test. And then you write just enough code to get the test to pass. Now, this is the key thing, only enough code to get that test to pass. And then you refactor. So I think we'll head over to code and have a look and see how this is actually working. So I'm just going to come out of my slides, and over here I have a project already set up, and I'll just give you a little guide through it. I'm using Rider here as my ID, and because I particularly like the testing suite that comes with Rider or ReSharper. So if you have a look here, I have some interfaces. Now, I have something called an iSubject analyzer, and this has a property which returns a bool called investigate further. And this takes something called an iSubject. So I also have iSubject available here. Let me get in there. Thank you. So this interface is called iSubject, and we have a string called subject name. And as you can see here, I have one implementation of that, and that's subject. So pretty straightforward. Now, if I come over and have a look at my test, I have simplified this project. I normally wouldn't have my tests within my project. I'd have a separate testing project, but I've kept it all together for the purposes of this. So in here, I happen to use NUnit as my testing framework. Feel free to use whichever one you like. I just happen to really get on with NUnit, so that's the one I use. So the first thing I have here, you'll notice, is a private iSubject analyzer, and it's called SUT, that's subject under test. So I know that this is actually what I'm testing. And I have a setup here, and I can initialize SUT in here. But this is an interface. So I actually need an implementation of iSubject analyzer to be able to begin my coding. So let's add that. I'm going to add it over here. And we'll call that subject analyzer. Good, no spelling mistakes. And let me just zoom in a little bit more in there. Okay, so this needs to implement iSubject analyzer. Okay, good. And we just need to bring in those missing members. Perfect. So now I have a solid implementation of that. Let me just put a space there. So you can see it's brought in our investigate further, and it's got throw new system not implemented exception. I'm super happy with that. I don't need to do anything further with this for now. So let's go back into our test, and I can actually complete my setup now. So SUT is equal to new subject analyzer, and awesome, I am ready to write my first test. So I just copied over my scan and see if they are of interest requirement, because that's what I'm going to be fulfilling. Okay, so with NUnit, I need to have an attribute called test. I don't need any parentheses, thank you. And I'm going to make this a public void, and I don't really mind what people call their test methods, just be consistent. I like to delimit mine with underscores and have what it is we're looking at, what it should do, and the outcome. So in this case, it's going to be Terminator should, and underscore determine underscore to investigate further. Cool. So I'll just make that into a nice method there. And the first thing I want to have is my result. So my result is going to be SUT, and then what we're testing is the investigate further method. And I've got red squiggles there because this is accepting a subject. Now I could new up my subject in my setup here, but I'm not going to in this instance. I'm just going to pop it in the method here. So if we go subject, and that is a new subject, go down here, and I'm going to initialize this straight away. And that is going to be subject name, and I'm going to say this is a woman. Okay, and then I can pass this in here. Let me just move this up a little bit for you, into there, and my red squiggle should go away. Awesome. So probably the key part of a testing method is the assertion, what we're saying should happen with our result. I like to use fluent assertions because I like their sort of readability as a sentence, but you can use whatever you like. So with fluent assertions, I have result.should. And in this case, I want it to be true. And I'm actually just going to tweak the name to investigate woman further, because that's what we're looking at. Great. So I'll come up here now, and I'm going to go to my tests, and I'm going to run my unit tests. So what this does is it goes and discovers all the tests I've written, and then you see it down here. And awesome, my test has failed. So that first thing I need to do for my red-green refactor has happened. I have a system not implemented exception. Yeah, because we've not written any code. So let's have a think. What is my code wanting me? What does my test need to be passing? It needs to be true. So let's go over and have a look at this implementation here. So you may be thinking, all right, so I'll take this subject and I'm going to do an if-else statement or a switch or something like that. Stop. What is the bare minimum amount of code I need to write to make my test pass? That is it. That's all I need to write. Let's see. Awesome. My code is passing. I've passed my test. So I've got my green. So I've done red, green, and now it's time to refactor or write another test. So I'm pretty happy. My code is returning the answer I want. So I'm just going to copy this. And down here, I'm just going to should determine not to investigate. And I'm just going to take women out. And well, if my Terminator sees a T1000, I'm not too worried because they're probably wanting to capture John and Sarah Connor themselves, and you know, we're all going for the same goal. So I don't want to go and investigate that further. So now I have Terminator should determine not to investigate further. I've got my subject updated, and I've got my result now should be false. Let's run my tests. I might just do them from here because sometimes they need to be rediscovered. And I'm hoping this will be a fail, and it is. So let's go back over to Subject Analyzer. Now I am going to do something with this. And I'm going to have if subject name is equal to woman, we're going to return true. And otherwise, I'm going to return false. Cool. And let's run all my tests. Awesome. I'm pretty happy with that. But I'm also looking for a boy. So let's go and copy this test here and pop it down here. And we're going to update the name to be boy. And I need to change the subject name to boy. And we want that to be true. So again, I can also click this little icon over here to run my test. And again, that one has failed. So I'll come back in here. I could be doing something else, but like switches and that, and my IDE is probably prompting me to do that, but I am just going to go boy and back over here, run all my tests. Good, success. But I'm going to do a little refactoring here. I don't actually like all of this investigate woman, investigate boy. The code is basically the same. So most of your testing frameworks will allow you to have a test case. And I don't want that type of bracket. I want that type of bracket. And what I can do is take this out as a variable. So I'm going to do that and pop it in there. I'm actually going to delete this test here because we don't need it anymore. And what I can do is actually stack these attributes. So I can now, there we go. And I can change that one to boy. And then what I have to do is just over here is I can pass in an argument to my test. So if I go string a subject name, and then I can take that and pass that into here. So now if we go and have a look at my tests, you can see I've got this test here. Oh, we should rename that as well because it's not just testing woman. So if we delete woman, so when should they go and investigate further? And you can see here, I've got those 2 test cases underneath. So let's run all of my tests. And awesome, they're still passing. And I'm going to do some more refactoring with this in a moment. But hopefully that shows you, like, just to get started with your tests and keep that focus and just, you know, hit those tests and answer them. So if I come back now to my slides, and let's have a little look at our next thing. So refactor, this is really, really important in test-driven development. It's one of the key things just to refactor. So I've got this investigate further method that we were just looking at, and I've gone and added in a few more things. So there's girl and man there. So I do get that with man and woman, there's some co-words in there, but that might become a problem later. But at the moment, this is fine. So what you were all probably screaming at me earlier was, let's have that as a switch. So I know there's the new C#8 switch, but I'm keeping it old school for today because I'm actually going to get rid of this switch too in time. So now we've got that switch, and I have all my test cases there. You can see I have now added man and girl into my test case, and that will go through and test for each one of those. And my failing test, or not my failing test, my negative test is still working. But now I have a requirement change. So let's see what our requirement change is. So now our T800 is protecting John and Sarah Connor, and he has also had the read-only switch on his chip changed over. So he can now learn new things. So he's going to be learning new things. So we know there might be new modifications coming in. And if you're wondering why you've never seen this scene, it's because it wasn't included in the theatrical release of Terminator 2. So there's a little bit of movie trivia for you. It's only in the director's cut. So we've got these new Terminator requirements, and that's protect John and Sarah Connor from threats, and we now have an ability to learn. So let's have a look at our code. I'm going to do another refactor of our tests to start with, because you'll see why. I have this T1000 now that I want to look at, and I'm adding that in because I think a T1000 is a threat, and I definitely want to investigate them if I see them again. But now, because I've changed my code, my test is now failing, and I don't like that. I don't like having to go and modify my tests unnecessarily for stuff like this. That's just, you know, unnecessary work for me. So this is where you can design your application to be more robust. And you do that generally by use of design patterns. Now, if you have looked at my Twitter profile, I'm sure you can probably guess what's coming next. Yes, you're right, solid principles. I am a huge advocate of solid principles, but I'm not going to bore you to death with solid principles and, you know, why you should use them. That's a whole nother talk. But what they are, let's just go through them, is the single responsibility principle, the open-close principle, the Liskov substitution principle, the interface segregation principle, and the dependency inversion principle. There they are in all their glory. However, for this talk, I just want to concentrate on the first three, So sol, the sunny side. The other ones are very important, but it's these top three that I think really come into play in your testing and particularly your robust applications and your test-driven development and helping you write the least amount of code. So let's look at these a little bit more in depth. So the first one, the single responsibility principle. Every class or module in a program should have responsibility for just a single piece of that program's functionality. So if you think about this with regards to testing, if you have a piece of code that needs to do so many different things, where do you start with your tests? What's your first test? How do you know that it's that bit of code that you're testing that's breaking and not the other part? So if you're finding that your code has multiple exits or you need that code to do multiple things, that's a real code smell, and start to break that and refactor it down into modules or functions that have just one piece of functionality. The next one, open-close principle. So software entities such as classes, modules, functions, etc. should be open for extension, but closed for modification. What does that mean? When I first saw this, I was like, I don't understand. What do you mean it's open for extension and closed for modification? How can I do the two? So I happen to think that the open-close principle is the least understood of all of these principles, but it can be one of the most powerful. So I am going to show you how we can implement that in a moment. The last one, the Liskov substitution principle. Objects should be replaceable with instances of their subtypes without altering the correctness of that program. We have already seen this in use. In my code sample, I showed you that subject analyzer, and I implemented an instance of that, which was the subject analyzer. But because of the coding contract we get with an interface, I can replace that subject analyzer with any other implementation of subject analyzer. So this is really powerful because the coding contract, the sort of signatures of your methods is the same, but you can have very different implementations of that. And this is like particularly useful when you have repositories and things. So you can have different implementation of your repositories, but all the tests will run the same. So let's see these three in action. Again, we're going to refactor. You're starting to see a pattern here. I like to refactor a lot. Right, so right now, this is what our tests look like. And I'm going to have another fiddle with my tests. You saw how we broke the Terminator should not determine to investigate further, the second one, by saying, actually, I want them to go and investigate the T1000. So we can replace that code with this. So we've got those test cases, but this will do the job of both of those tests. So let's just have a closer look at that. So in my test case, I now have two arguments. So I have the woman, which is a string, and that will be passed into subject name. And I have true, which is a bool, and that will be passed into outcome. So our subject name is going to go into that new instantiation of subject in that initializer there, and we'll be passing that woman or whatever that string is to be the subject name. And then our second one is going to be that bool. And you can see here I have updated the result from should be false or should be true to equals. So this in this fact, it will say result should equal true. Or if we're testing for girl, it's going to say result should equal false. So now I've combined all of that code on the left into this much smaller, easily sort of modifiable test case there. And if I run that, it works exactly the same, and we get everything coming through as a success. So that's a really nice way of refactoring and using test cases. Test cases can get more complicated. You can pass objects in there, but then you need to do some wizardry with how you instantiate those objects. So, but again, that's a topic for another talk. So I want to just go and return to our code here. So right now, our investigate further has this switch, which we refactored our original if statements into this tidy switch. And currently we have the iSubject interface and the implementation of that called subject. So that's pretty straightforward, but now I am going to add in a new interface, and that's called iSubject rule. So this has two properties or methods, and that's isMatch, which takes a subject. That could be an iSubject as well, so it could be the interface or the implementation. And then I have this bool, which is of interest. So what am I going to do with that? Well, I'm going to have a look at what I've got in my switch and do an implementation of iSubject rule for each one of those cases. So the first one I have is woman rule. And you can see there it's an implemented iSubject rule, and that of interest. Well, we know from our switch statement that of interest is true. We are interested in checking women subjects out. That sounds terrible, I apologize. So if we see a woman, we need to investigate further. Okay, and then we have our public bool isMatch. So is the subject being handed in a match? So that takes the subject in and it will return true or false if it contains the word woman. So you can see where I might come into trouble if I pass in for a man rule, because woman contains the word man, but we're not worrying about that. But this isn't flawless, okay? So I've got this is woman rule, and I've also got an is dog rule. So in here, of interest is false because we're not interested in dogs. And then I have the isMatch. Does the subject name contain dog? Okay, so what you could say though for this isMatch, this is a very simplified version of this implementation. We could have something that if subject contained an image, for example, we could go away and compare our image to in cognitive services and say, is this a woman in this image? If so, we want to go and check it out. So we could definitely start to refactor this code. But right now, it could do exactly the same thing. So we could change that implementation, but it's still going to return true or false. So this gives us a lot of flexibility. So let's move on to how I change this switch statement. Now that might be a bit of a shock to you on the right. There's a lot of code. It looks very, very different from our investigate further method on the left. So I'm going to go through it nice and slowly for you. So let's have our rules on the left, and we'll see how those are implemented and utilized by our subject analyzer class. So the first thing I'm going to do is create this private read-only list of iSubject rule. So we've got this nice collection, and I've called that subject rules. And I've also added in a default constructor to my class. And this is quite key for what we're going to do next. I'm going to new up my subject rules, and it's still a list of iSubject rule. And the beauty of that is that this collection can hold any implementation of iSubject rule. So that's what we do. I'm going to add in subject add new is woman rule, as you can see here. And I'm also going to add in a new is dog rule. So now my collection holds those two implementations. So now if we go over to our investigate further, let me just go back there because I came off my screen. It still takes a subject. It still has the exact same signature it had previously when we had it as a switch, but we've just changed the innards. So I'm hoping that this won't break our tests. I'm not hoping. I know it's not going to break our tests. So the first thing we have is this isMatch. Probably not the best name. I could rename that, but let's think about this as a matching subject. So I iterate through my collection of subject rules, and I find the first or default instance of when I have a match. So if you look on the left, if I add in, if my subject has a subject name of woman, it will go through and it will pluck out that is woman rule. That's our matching rule. The dog rule won't match, that would be false. We go and find where it's true with that is woman rule. So now we've got that is woman rule is the equivalent of our is match. That's our object left over. So then if we don't find a match, it will be null and we'd do something else with it. But if it's true and we have got an is match, we're going to investigate that further. And that's where we use this little private method down here, and that's investigate. And that takes that subject rule and it will return that bit of code on the left that says public bool of interest, return true. So it's very simple. It just goes and gets whatever the contents of that of interest method are. So whatever that's supposed to return. So that's quite a lot of code there and a little bit complex, but hopefully that's come through. Now I do want to touch on private methods. If you need to make a private method public in order to test it, then it's time to refactor. It's a real code smell. So I remember seeing private methods and I'm like, oh my goodness, I have to test it. Oh, but to test it, I'm going to have to make it public. And then I'm going to have to modify my interface. And that should ring alarm bells. If you're having to make it a private method public and modify your interfaces, then you're breaking those coding contracts. You may break other code because then you'll have to go and implement it in your other implementations. So it's time to pull that method out, create an interface for it, a new class for it, and handle it that way. It definitely shouldn't just be made public and you shouldn't modify your interface. Okay, so I've run my tests with my new code and lo and behold, they all pass. I haven't had to modify my tests. They're just going to work because we've got that coding contract. I've written my tests first. I know that we're fulfilling all of our acceptance criteria and I've refactored till my heart's content. So why is this method better than that switch statement? Well, this fulfills open-close principle. If I want to extend the functionality of investigate further, all I have to do is create some new rules and add them into my default constructor as a new item on my iSubject rule collection. I don't need to touch my investigate further method. I don't need to modify that at all. And I know that I don't have to modify my tests because I've tested iSubject rule. And I know that if something implements iSubject rule, it's going to pass because I've got that coding contract. I have my acceptance criteria. I know that it's all going to be fine. So I can add new subject rules and I don't have to go and modify my code or my tests. So this is where it becomes very powerful and you can start to see where your return on your initial investment of coding in a robust fashion and writing your tests first starts to speed up and you get that increase in productivity as you go along. So I hope that shows you a good example of the open-close principle because that investigate further is now closed for modification. I don't need to modify it at all, but that I just need to extend its functionality by adding in new rules. So with good practices, code management becomes infinitely easier. We just don't have to worry about writing new tests when we modify things or add in that new functionality if we've written it well. So TDD failures. feel like this should have come before the TDD successors to fulfill my red-green refactor, but I think it fits in better here. So where do people fail with test-driven development? I think the biggest thing is underestimating the learning curve. I certainly did. When I wanted to start, I found that I couldn't make progress. I didn't know how to begin. And I think if you were trying to implement this in your team, you'd need to be super understanding and have a lot of empathy for the actual learning curve of this mindset. It is very, very different to go through this way, and people just underestimate that. Confusing TDD with unit testing. You might think, well, how do you do that? Well, consider this. I wrote my first test. I haven't written any code yet. I've done my test first. I then go into my implementation and I do exactly what I said we shouldn't. I don't return true. I go through and start going, oh, right, well, I'm going to need an if-else statement. I'm getting ahead of myself, basically. We know that I'm going to need to have a look at what the contents of subject are. I'm going to build a switch. And I've built and written all of the code, but I've still only got that one test that says, well, I'm expecting this to be true. So when I finished my code, I go and look at my tests. That one will fail because, well, it might not fail, but I then have to go and write all the tests that test all the other aspects that I've already written. So I've actually just written unit tests after the fact. I started with one test first, but then I wrote all my code and just did some unit tests. And that was something I started doing. It's like, oh yeah, I'll do this. And I had to stop myself and say, no, red, green, refactor, write a test, do some code, go back. So I think some people do confuse TDD with unit testing. Thinking TDD is enough. I've been there as well. So I worked for a company where we had extensive TDD. We had test coverage on our build server. It's awesome. But we didn't have any integration tests. We didn't have any real user acceptance tests. We didn't have any testers. We didn't test our work. So we were wholly dependent on the unit tests that were in our TDD. That's not good enough. You need to have it in conjunction with other ways of testing. Not starting with failing tests. Well, I find it very difficult to know how, if you haven't written any code, how your test doesn't fail, to be honest. But this is key, because if you've written a failing test and the code that you write fulfills that failing test, then you know that you have met your acceptance criteria and that you have now got code that does exactly what you want it to do. Not refactoring enough. So this comes back to that, possibly the private method, making that public, rather than refactoring that private method out into its own class or whatever is required. You just make it public and fiddle around with it. It's really important to keep fiddling and keep refactoring and get into this red-green refactor if that's the method you're going to use. But just be snappy with it. Run your tests every time you change some code, and then you'll pinpoint your errors much faster. Not actually doing TDD. Well, any of these ones up there, if you're doing that, you're not actually doing TDD. You're fooling yourself. So that's where TDD can fail. And this leads me on to implementation within your organization. So how do you get that into your workplace? It can be controversial, and there is a significant culture change. Not denying that. This is a shock. I think it would be unwise and unfair to go to a development team that's midway through a solution or a production code and say, right, we're going to do TDD now. The culture shock would lead them to be very disheartened. That initial drop in productivity would be very disconcerting. And I think this is something that you really need to bear in mind. It's not something that can be implemented overnight. It's a complete shift in how one approaches code, approaches the requirements. Everything needs change, and you need to have empathy to get this in. I think the best way to start is with a fresh solution, and you give your team the time and support they need to make this big change. However, if you stick with it, productivity will go up and the reworks will be reduced. And I think the biggest thing here is that you're going to reduce your technical debt, because you are investing time, but what you aren't doing is accruing technical debt, because you're going in and you're laying all this fantastic foundation with all your tests and all your requirements being properly assessed and the criteria documented. And then, as you can see, if you need to extend the functionality, you can get that in really quick without modifying your code or modifying your tests. So you really ramp up your productivity and your throughput. And another great one is that increased understanding of requirements and their acceptance criteria. Because as I mentioned earlier, it's very hard to write tests without clear, concise requirements and their acceptance criteria. So you've pushed that back onto your project manager or whoever writes your requirements and user stories, and you've said, I need more detail. So they've understood it more, and you've understood what they want from you more. So everyone's a little bit happier, and you get less of this misunderstanding at a later date. So a few weeks ago, I did a Twitter poll, and I asked, when starting test-driven development, or when starting new development, what stops you from doing test-driven development? So I had quite a good uptake on this. 276 people took part. So let's have a look at that first one. I just need to move this window a bit so I can see everything. And this is going to click over, so just bear with me. Okay. So adds too much time. 18% of people said this adds too much time. Now, I would have to say that I think they're not sticking it out. They're not persevering. They're in that stage where their productivity has dropped and they're getting disconcerted. They're like, oh my goodness, we've got so slow. We're not doing that churn of production code that we were before we started this. And if they only stuck it out a little bit longer and persevered, they'd start to see their productivity ramp up exponentially. So let's look at the third one there. Not sure how to start, 23%. I think that's quite a significant number of people who don't know how to start. I would have been in that bracket. And I hope that in this talk, I've given you a little bit of an idea on how you might be able to start your learnings with test-driven development. The bottom one there, 13% of people said they TDD all the things. I think you're lying or kidding yourself. I did get some comments that, oh, well, I write unit tests afterwards, so I tick TDD all the things. I think we've got a few people in there who are in the TDD failures category. I'm sure some people are actually doing TDD, but I'm sure some of them only think they're doing TDD and they don't really. And then a whopping 46% of people said that they like to hack first. So in response to that, I asked another question. So I said, well, I actually asked two questions. I was quite demanding. So for all of you answering, I like to hack first, I have some more questions. Number one, after hacking, do you retrofit tests or do you start fresh with TDD using your hack as a spike? A spike is like a proof of concept in Agile speak. You go off and do a quick test, and if it works, you reintegrate it back into your project. So many people said that, oh, they did sort of some unit tests afterwards. Very few people said that they would implement the tests in their project and start bringing that spike code or that hack code back in. And number two is where I felt it got interesting. When you start hacking, do you have a clear idea of what your outcome should be? Now, nearly everyone who answered me here goes, no, that's why I started hacking. But I want to counter. What are you hacking on if you don't know what you're trying to get to? So I think you must have some idea of your outcome if you're hacking on some code. So, for example, if you want to hack on a new API endpoint, well, you know that you're going to return an okay result and some content. For a start, you may want to do other stuff, but you definitely know that you're going to return something on this API endpoint. So why not start with a test that just says, hey, I'm expecting this to return an okay result. Now your code can do all sorts of things in it, and you can start refactoring it out and having those tests come in as you go. So you can loosely do TDD on your hacking, and then you know that when you've completed your hack, that you have actually met what you've set out to do. So I think that you can definitely do it. Now, I don't want to sound dogmatic, and you're probably thinking, oh, she's sounding a little bit dogmatic. I think you should definitely be pragmatic when you're coding and doing TDD. If you really are just going to do a quick proof of concept to actually see if something can be done, go ahead. Don't worry about tests, just do it. Just think about your tests when you come to bring it into your production code. And also, just going back on that empathy earlier, I just wanted to share with you that when I first started at a company that did TDD, I sort of did that failures one, and that was back here. So, oh, not even there. I wasn't even doing confusing TDD with unit testing. So I'd write a test, then I'd fulfill all my code, and then I'd write some tests after it. Well, my team lead threatened to delete my entire coding for that day because I didn't do it with TDD. That's dogmatic to me. Don't do that to your people. Be kind, help them. They're trying at least to progress and write their code, their tests first. And it is a learning curve. It is a process. So just remember that. So if you take one thing away from this talk, and I hope you take more than one thing, but if you are only going to take one thing, then let it be this. Write the least amount of code to get your test to pass. This was that aha moment for me. If you need to return true, oh, we skipped too far. If you need to return true, then simply just return true. And with that, I am going to say thank you very much. My name is Layla Porter, and you can find me on Twitter at Layla Codeset. You can find me on GitHub, Layla-P. If you want to look at my original TDD and the Terminator code that I did back in 2017, it's on my GitHub, buried under a whole load of projects. It will be there. You can go and find it. If you want to email me about anything, you can find me at lporter@twilio.com. I've also just created a bit.ly link to the code I've written here. I will be updating it with the code I've just written. So at the moment, it's where at the starting point. So that's on my GitHub, but I've got this bit.ly link here for you, TDD-Terminator. And then if you want this deck, I have also published that to Speaker Deck, and you can go through and have a look at that. That's bit.ly TDD-deck. So I think, Martin, we've got a few moments for some questions if there are any, but I'd just like to say thank you for listening, and I hope you enjoyed that as much as I did.
All right, thank you, Layla, for a fantastic talk. I found it really interesting, and looking at a number of the questions that are coming in, a lot of people also found it interesting and have a bunch of follow-up questions, actually.
Okay.
You gave a lot of pros on TDD.
Yep.
Is there any specific con you would say?
I think the biggest con is how your head works and slowing yourself down. And you may feel that you're almost being dogmatic with yourself, that I know what I want to write with the code, and you may cheat a little bit. And I'll admit, I do cheat. I will write a collection of tests that I know I want to fulfill, and then I'll go and write my code. I don't always stay super true to my red-green refactor in the method I showed you. However, if the code is more complex, I definitely will. So I think there's a tendency to cheat. So as I said, just be kind to yourself. And I think people can be very dogmatic, and I think that's probably the con. People get militant about doing TDD, and you should never be militant and say that there's only one way to do things. There's never only one way to do things.
All right, thank you. Then another one is, what if you have an existing code base to work with? How would you start introducing TDD inside of that code base?
Okay, so I definitely think you can do it. I would just start to have, if you've got tests in there, then you're already winning. If you don't have tests, you just need to set up your test environment. So you'd get a test project in there. And I would start with a fresh user story, for example. Go and get your requirements and just do it. Just grab your interfaces. You may already have the interfaces written. If you don't, go and write some that fulfill your requirements, and just be patient with yourself. If you lapse into the old way of doing it, don't worry. It's a process of learning. So you definitely can, but just be mindful that it's slow going to switch yourself over, and especially if you've got a team of people in there with you and you're switching over to it. Just be patient, be kind to yourselves, and just as long as you're trying, you'll get there.
All right, thanks. And then maybe one more, a couple of questions around testing UI and graphics-heavy applications. Could be web, could be WPF. How would you go about testing those?
So I think automated testing is the way to go with it. I've forgotten the, Selenium. That's what we used, and we had a whole load of automated Selenium tests that would go through. And if you made a UI test, those a change, those would fail. So you can definitely, that would be more on a web project. I don't know how that works with a UPF, or did you say WPF then? In that respect, because I only really do web development. But you can use a front-end testing framework. You write all your tests, and that automatically goes through just the same way. I'd definitely say set up a build process that runs all of your tests, possibly before you even commit as well. So you can definitely start to go through your front-end testing in an automated fashion in the same way.
All right, yeah, and probably it could also help testing just a view model, for example, and not testing the actual UI, if you can live with that.
Yeah, that would definitely help. So you know what's coming out of your endpoint into your view. It is kind of what you want. So you know that the data is going to be okay, even if your input boxes aren't in where they should be, for example.
All right, yeah, I guess we're through the questions. Thanks again for a very interesting session, and let's quickly switch back to my screen here for a couple more things.
Okay.
All right, so if you want more information about Rider, you can follow us on Twitter or find our blog. We will publish the recording of this session afterwards on JetBrains TV, which is on YouTube, and we'll also make a blog post about it. Again, if you would like to follow Layla on Twitter, her Twitter handle is there. And if you're interested in future webinars that we have, we typically announce them on our blog. And the next one is on October 8th on better Xamarin development with Rider for Mac. With that, thank you for joining. And again, find recordings and more screencasts and webinars on JetBrains TV. See ya.